Today we are doing the same thing we've been doing. We're solving systems of equations. So you're finding where two graphs intersect, which is at an ordered pair, except for we're doing it without the graph today, so it's completely algebraic. There's two methods that we have learned in your past, like probably 3 previous courses. Substitution or elimination. So I'm going to go kind of fast through this because you should have done this in Algebra 1. You should have used it in Geometry and Algebra 2. So this should be review until we get to the last part of our notes. So we're going to start with substitution. Substitution's helpful if something's already solved for x equals or already solved for y equals. So that's when substitution's helpful. Here, this says y equals 7 minus x. So I'm going to substitute what y equals in the second equation for y. I'm going to pull out y, I'm going to put in what y equals. So I'm going to have 7 minus x is equal to negative 3/2 x plus 6. So I substituted in for what y equals into y. And then you look at this new equation. Are there any, is there only one variable? Yes. If there's only one variable, it's all x's, then I can solve for x. If you still see 2 variables, you've done something wrong. I mean, it happens. Now, I don't like fractions, so I'm choosing to multiply everything by 2 so I don't have to deal with fractions. You don't have to do that step, but I'm choosing to. So multiply everything by 2, and I get 14 minus 2x equals negative 3x plus 12. And now I'm just solving an equation. We got x's on both sides, so I'm going to add the 3x to both sides. And I'm going to subtract the 14 from both sides. And I get x equals negative 2. So we get x equals negative 2, but we need to know what xy is because it's an ordered pair. So what we're going to do is we're going to do this next step where we plug in our x. You can plug it in either original equation. I'm going to label them 1 and 2 so we all know which ones I'm talking about. Which one would you like to plug in x in? 1. Okay, we'll plug in 1. The most mistakes that I see on this kind of stuff is people who do not stay organized and their work is everywhere and they can't read their own handwriting and they're not doing all the steps that I've given you. As a 17-year teacher, I've seen all the mistakes. So trust me when I say do all these steps and you're going to do a lot better than if you don't. So I'm going to plug in y equals 7 minus x. I'm going to plug in x is negative 2. Y equals 7 minus negative 2. So y is 9. My next step, once I've plugged in 1, I'm going to check in 2. So you have to use both equations in this step. You plug in 1, check in 2. If you plugged in 2, then you check in 1. You have to use both equations. So we're going to check in 2. Y is 9 equals negative 3/2. Our x is negative 2 plus 6. If 9 equals, remember when you multiply fractions, you put the negative 2 over 1, you go straight across, reduce. I get 3 plus 6. Yes, that's true. Minus 3 plus 6. So you plug in 1, check in 2. If everything checks, you have your answer. Negative 2, 9. We write it as an ordered pair. So what happens if you go through all the steps, you plug in 1, you check in 2, but it doesn't equal? That means you made a silly mistake. Go find your mistake. So that's why we do that check in 2, so you have the opportunity to know if you got it right or wrong, and go fix it. Next example, one more substitution. You look and you say, is one of the equations already x or y equals? Yeah, the second equation. So when I look at equation 1, I look at equation 2. This one's already solved for x, so I'm going to replace x in my first equation. So I will write 3 parentheses, negative 1/2 y plus 4 minus y equals 2. So I read the whole equation 1, but I put equation 2 inside of it. Substitute. And then we'll simplify. I'll distribute by 3. I've got to multiply fractions here. So negative 3/2 x or negative 3 has y, sorry, plus 12 minus y equals 2. I don't like fractions. So I'm going to multiply everything by the denominator to cancel out the fractions. So I get negative 3y plus 24 minus 2y equals 4. Do I have just y's? All y's. So I can solve. If I had other stuff, then I did something wrong. Combine my like terms, move my 24 to the other side, I get negative 5y equals negative 20, and divide, I get y is 4. So once you substitute, you get y equals 4, and we now have the two-step plug in something, check in something. So I look at my equations, and I'm going to plug in 2 this time. I'm going to plug in 2 first. So I have x equals negative 1/2, y is 4, plus 4. So x equals negative 2 plus 4. X is 2. So if I plugged in 2, I have to check in 1. You have to use both equations in this step. If I plugged in 2, I check in 1. So we'll do 3 times 2 minus 4 is 2. 6 minus 4 is 2. Yeah, check. So then you write your solution to 4. And again, if you got through all of that and then you went and checked your answer and it didn't work, if it didn't check, then you made a mistake. Go find it. If you have all the time in the world to rush through it the first time and then have a mistake and go back and fix it, if you have all the time in the world, go for it. If you don't have all the time in the world, stay organized and do it right the first time. Okay. Next 2 examples are by elimination. So different process. When you do your assignment, some are going to say to do by substitution, some by elimination. On quizzes and tests, I really don't care which way you do. But we'll practice both ways, so you're prepared. Elimination, that's the kind where you add up the 2 equations and something like magically cancels out. Remember that one? You add them up. But it's not going to work as is right here. We're going to have to multiply one of the equations. So equation 1 or equation 2, which, different question, which variable should I try to eliminate, the x's or the y's? Yeah, so equation 1 or 2, I should multiply 2 by 5. Yep, you guys remember this stuff, right? So equation 2 is now negative 5x plus 10y equals 15. We add them together and our x's eliminate. And we get 7y equals 13. We divide both sides by 7 and we get this lovely answer of 13/7. Oh my gosh, it's a fraction, it must be wrong, right? No. When we were doing graphing, I didn't give you answers that landed as fractions because it's too hard to see that when you're graphing. It's almost impossible. But now we're doing solving by algebra, we can get fractions. So we got 13/7. We got an answer. So now we're going to plug in that answer. Which equation would you like to plug in 13/7 for y? Which equation? 2? Okay. So we'll plug in 13/7 into 2. So we have negative x plus 2 times 13/7 equals 3. So to multiply fractions, we put 2 over 1. To multiply fractions, you go straight across. We have negative x plus 26/7 equals 3. We have to subtract 26/7 from both sides, but when you do subtraction in math, you always have to have like terms, and these are not like terms. What do I mean by like terms with fractions? Common denominator. When you subtract, you have to have common denominator, like terms. So how do I make sevenths into 3 total wholes? How many sevenths are 3? 21 sevenths. So now we have negative x equals, we subtract 21 minus 26, that's negative 5 sevenths. So x is positive 5 sevenths. So if I plugged in 2, we check in 1. If I plug in 2, we check in 1. So 5 times 5 sevenths minus 3 times 13 sevenths has to equal negative 2. Multiplying fractions, put 5 over 1, put 3 over 1, multiply straight across. I've got 25 sevenths minus 39 sevenths equals negative 2. We have common denominator. We've got like terms, so we can subtract them. 25 minus 39 is negative 14 sevenths equals negative 2. Is that true? Yay! Then I can just write my answer and be done with the sevenths. I do like the numbers though. 5 sevenths, 13 sevenths. Done. If you're going to use your graphing calculator and you're going to use the intersection tool, which I haven't showed you yet, but we will go over that in here so that you know how to use it. If you were going to do that, it's not going to tell you 13 sevenths. It's going to give you some horrible decimals. So you want to be able to do it algebraically. I am going to skip B because of time. It is going to be more fractions. So just heads up, you're doing it. Yeah, it is. Now, example 3 is new stuff. How about one new? Not previous course. It's kind of previous course, but not. What's different? It's called the x squared. We're going to do it by substitution, so we need to solve either the first equation or the second equation for one of the variables. I'm going to give you a hint if you want to make your life as easy as possible. Do not solve for the variable that's squared. Okay? So when I look, I hope everybody here agrees, yeah, let's solve the second equation. I hope we agree. Let's solve the second equation, but don't solve it for x. Solve it for y. It's going to be easier to solve it for y. Trust me. So I'm going to make the second equation y equals. I'm going to add the y over. I'm going to add the 1 over. I'm going to get y equals 2x plus 1. And then whatever y equals, I'm going to substitute it in for y in the first equation. If I'm going to use parentheses, I'm going to stay organized. I'm going to make sure I can read my own handwriting later. These are all the things I see lots of mistakes with. And I'm going to use those parentheses because there's a minus sign in front of the y. What do those parentheses tell me that minus sign has to do? If you don't use those parentheses, you probably forgot to distribute. I see it all the time. So we have x squared plus 4x minus 2x minus 1 equals 7. And I can combine my like terms. I've got some x's here, like terms, x squared plus 2x minus 1 equals 7. Okay, so now we have to solve when there's an x squared involved, and we have reviewed how to solve when there's an x squared involved. What's the first step? Before factor, what's the first step? Set it equal to 0. So when you've got an x squared involved, make it equal to 0. So we're going to move that 7 over. We're going to get x squared plus 2x minus 8 equals 0. And yeah, we were solving by factoring last week, and this is why, because I knew we were going to have to do it this week. I haven't really given you any that you can't solve. Not really. So we're going to factor. Remember, always look for a GCF first. This one doesn't have it. A trinomial means guess and check. The minus 8 means there's going to be 1 plus 1 minus. it's going to be a positive 4, a minus 2. So we solve it by factoring. What happens after you factor? Set each factor equal to 0. So we have x plus 4 equals 0. We have x minus 2 equals 0. So we have x equals negative 4 and x equals 2. Our ultimate goal is that we are trying to find the ordered pairs where these two graphs cross, and we have 2 x's. So that's telling me we're going to have 2 sets of ordered pairs. So we're going to plug in x twice, or different x's, I mean. So our next step is plug in. Which equation would you like to plug in next? Which equation? 2? Okay. But we got to plug both of them in. So I'll just try to stay organized here. There's where I'll plug in the first one. So we'll do 2 times negative 4 minus y is negative 1. And move the 8 over. I don't know why this is like that. So I get y is negative 7. Other side, same process, just different number I'm plugging in. Move the 4 over, we get negative 5, divided by negative 1, we get let's see. So I plugged in 2, that means I'm going to have to check in 1. Both. Both. All right, so x was negative 4 squared plus 4 times negative 4 minus y is negative 7 equals 7. So we get 16 minus 16 plus 7 equals 7. Yep, checks. Second one, we've got, what's x? 2? No, yeah, 2. Was it 2? 2 squared plus 4 times 2 minus 5 equals 7. 4 plus 8 minus 5 equals 7. Yep, that works. So we'll check them both. And since both work, I know I haven't made any mistakes. I can write both solutions. Negative 4, negative 7, and 2, 5. I have a set of solutions. What? When we did the what was it, like 2 nights ago, I think it was, or that's how I showed the solutions. So when you have like multiple answers, you want to write them as a set, a collection of answers. All right, I'm going to skip B because of time, but we'll do C, most of C. We're going to do most of C. So substitution. Look at the 2 equations. Which one should we solve for a variable? Huh? We're doing C.
Oh.
I know. Let's try that again. Look at C.
The second one.
Yeah, we're going to solve the second one. Which variable should we solve the second one for? Doesn't really matter. I'm going to solve it for x just because it's like one less step. But either way, when you go to plug it in up there, both x and y are squared. So either way, you're going to have the same amount of work, with the exception of just solving this one. So I'm going to make this one x equals, I'll move y over, so y plus 2. Now, in the first equation, wherever you see an x, we're going to replace it with y plus 2, and there's multiple x's. Wherever you see an x, parenthesis y plus 2. So we'll have parenthesis y plus 2 squared plus y squared minus 4 parenthesis y plus 2 close parenthesis minus 4y equals negative 4. So make sure before you do a bunch of work, is it all y's? Is it all y's there? Don't have the extra x's stuck in there. So just solve what we're we're going to have to get rid of these parentheses. How do I square y plus 2? You write them twice and you FOIL. Please do not harm any animals. Do not just square the first and last term. That is not how you square that. You write y plus 2 times y plus 2. You use your FOIL. You combine your like terms, and you get y squared plus 4y plus 4. Try it. Then we'll bring down our plus y squared. We will have to distribute the minus 4. So get minus 4y minus 8 minus 4y. And while I'm at it, I'm going to go ahead and add that 4 to the other side of the equation. You know, while I'm doing all the work anyway. Combine some more on that side. I'm going to have to solve it where I'm going to have to set it equal to 0 eventually. Now, when you combine your like terms, stay organized. As I'm combining my like terms, as I'm adding them up, I'm crossing them off so I don't miss anything. I'm going to add y squared plus y squared, get 2y squared. I'm going to add 4y minus 4y minus 4y, get minus 4y. 4 minus 8, that's minus 4, plus 4, 0. So as I'm like adding my like terms, I'm just crossing them out so I don't miss anything. And you just get 2y squared minus 4y equals 0. Factorable. How do you factor out, what do you do first? I said it almost.
2y.
Factor out the GCF, 2y. Y minus 2. Set each factor equal to 0. And we get y is 0 and y is 2. Which equation should we plug in?
People are playing really bad. Just
Yeah.
a little bit.
Oh, I am going to the stuff on it. Which equation should I plug it in? Second one? Both of them into the second one? Going down a little bit. Is that okay? Okay, what is my second equation? X minus y equals 2. Okay, so we're going to do x minus 0 equals 2, so x is 2. That one wasn't too bad. And then x minus 2 equals 2, so x is 4. After you do plug in 2, then what do? Check in 1. That one's going to be a little bit more of a pain. I will tell you, though, right now, some of the homework, you won't have to do the check step. Some of the homework, I've given you questions that they already like graphed, and it says check using a graph. So instead of check with all that algebra, they've already graphed it, and you can go and look at your graph and go, oh yeah, that's my 2 points. I did it right. Okay. So some of the questions I've given you the graphs so that you don't have to do that check step. You just have to write your solutions. What are my solutions? 2, 0, and 4, 2. Okay. So this, if there's no graph, you are going to have to do that last step of check. If there is a graph, then that's your check. It's just look at the graph.
Were there not 4 solutions because there's an x squared and a y squared?
No, the x squared and y squared means it's a circle. And then the second one is a line. So there's only 2 maximum solutions for a circle and a line. Okay. There are a couple in your homework that have 3 solutions. You'll see them like I have graphs and it looks like that, and there might be a line that crosses through 3 times. That would probably be the max I think that I gave you for homework is 3. But they're not going to be horrible answers. They'll be easy to check. All right, we're going to do one more thing and then we'll be done. The last thing is just talking about the different kinds of solutions. And again, this is a repeat from previous courses. If you graph or if you, is this thing imaginary? No. Okay, so if you graph and if these 2 lines do not intersect anywhere, that would be a no solution. So if you'd like to write no solution without all those letters, that symbol means no solution. That symbol means no solution. The second example, we've just already done a bunch of them. They cross at one point, so you have like a solution as symbol repair. The last one we haven't done any of yet. If you graph them and they're the exact same graph, you've got infinitely many points that they have in common. So you can't write all the points they have in common. So instead, we're going to write the equation that they have in common, and this right here shows you how to do it, but I'll show you a real example with that last section. I'll just show you exactly what I want you to do if it's infinitely many. So for this example, oh, it's still there. Great. For this example, it must be the other thing, but I don't know how to get rid of it. This example, if you were going to do this by elimination or substitution, what would you do? You do substitution? Is that what you're saying? That's fine. I would. I would do elimination, but it's totally up to you. I'm going to say you can do it however you want. But if I look at these and it's already set up, and I multiply the top one by -2, I can cancel out my x's. So my x's cancel out. Then I add my y's, but oh no, what happened? My y's cancel out. So I get 0 equals -9. So can I solve for x or y? I can't. Does 0 equal -9?
No.
It doesn't. This is a no solution. This is not the same thing as if you did the check step and it didn't check. This I can't even find an answer for. Okay? This is different than checking it. What?
Do you have to do it that way, or can you just check the slope and like see if they have
You could,
the slope?
yeah, that's fine. I mean, if you get no solution, there's not much work. If you see they have the same slope, but a different y-intercept, then it's no solution. This one I'm skipping. This one does have one solution, but we've already done one solution. This one is the one that has infinitely many. So I would do elimination. I'd multiply this top one by -2. I'd get -4x plus 2y equals 2. I'd add them up, and oh my gosh, my x's cancel and my y's cancel, so I get 0. And then on the other side, the number cancels too. So I get 0 equals 0. Everything totally canceled out. That means these are the same equation. There's infinitely many solutions. This is how we're going to write our answer for infinitely many solutions. Fancy bracket, because there's more than one answer. You're going to say all the ordered pairs for a specific line. Y equals. Now, how do we find that equation? Move your y over, move your 1 over. So just solve one of those equations for y equals, whatever one looks easier. And we write 2x plus 1. So the way I'm going to write the answer is you're saying set notation, all the ordered pairs where y equals 2x minus 1. That's how you write all the ordered pairs. If I went super fast, this video will be on Canvas. The notes will be on Canvas. Your notes are in. Like, use your notes when you do your assignment. It is in the book. So if you do not trust Canvas, make sure you take a picture of the book before you leave, so that you have it. Get somebody's phone number just in case Canvas doesn't work. The book is uploaded on Canvas. It is uploaded on Canvas. The book is uploaded on Canvas. It's made for me. Yes, if you'd like to check out a book, grab one, get your name in it, and then I need to get your information. Let me just stop this video and I'll put the homework back up. Don't take pictures of me.